Hi, so this is the second of our brief video clips, and we're going to talk about multiplication again for the purposes of your midterm coursework, assessed coursework. And the first thing I want to, no, there are two things I want to do. First of all, the first video clip concerned the definition of functions in Python. I forgot to mention the fact that the code, for example, the doc string and the body of the function will be aligned to the beginning of the name of the function. So, for example, if the name of the function is indented by 4 spaces, then the rest of the code and the doc string and everything else will be indented by the same number of spaces. And we could have subblocks within that. For example, we might have a while loop within the body of the function, in which case, after you've written the word while, the block of code that's to be repeatedly executed will be indented by a further number of indented spaces. So it's quite easy to get familiar with that idea, and it saves having to write brackets to indicate what's actually a block of code to be executed in sequence. So anyway, we're here to talk about multiplication. And the second thing I want to say is that I want you to try and relate what we're about to do to what the work we did in week 2. And in week 2 we were looking at computer architecture. And one of the important things that we did within that session, within that topic area, was to come to understand how, using the very simple computer architecture and the opcodes that we were introduced to, for example, the store keyword, the store opcode, the add opcode, the move opcode, and so on. And we actually came to realise that there's no opcode for multiplication, and therefore we had great fun in writing a fairly short sequence of assembly instructions. In other words, instructions written in terms of opcodes and addresses. So, for example, I could write move whatever's in memory location A into the accumulator. And another example might have been add the number found at location Y to the integer currently stored in the accumulator and leave the result in the accumulator. So that's important, and I think part of the coursework's actually asking you to think about some assembly, some low-level programming instructions. And when I talk about an opcode, for example, move followed by the name of address, what I'm actually directly referring to is a binary representation of the opcode. So, for example, I can't remember quite what it was, but it's something like 010, and then give something like an 8-bit address, memory address. Anyway, what I'm here to do now is to talk about how you can actually perform multiplication, ultimately by writing a function to do it, but primarily I want you to consider the use of the while loop to do that. And we were introduced to the while loop last week. And remember, in Python, a while loop consists of the reserved word while, then a condition followed by a colon. So here the condition is If, in a sense, is if the value of count is strictly less than n, do the following. Well, what do we mean do the following? Do the following block of code which has an equal indentation from the beginning of the while the letter beginning of the expression while. So here I've got, I think it's two spaces again. Maybe I've got 10 more instructions, all indented by two spaces. So whilst that condition is true, what I want to do is to repeatedly iterate through this block of code until this condition is false, in which case the execution of the instruction or command, which is exactly aligned to the W of while, will be executed. In this case, it's going to be print the value of the variable total. So let's have a quick look at that. And last week I did actually introduce you to these quite useful operations given by the reserved word input. Input takes a string parameter, it could be empty, but what's going to happen is that this string is going to be output on your terminal, on your screen, and in this case its input is going to expect me to type something in, and other things being equal, it'll be converted and stored as a string, but I'm going to cast the string to an integer value and then assign the resulting value to an integer variable z. So for example, if I typed in the letters, the alphabetical letters 1, 0, it's just a string, the string is going to be converted to an integer, namely 10, and then assigned to z. And similarly, if I execute this line, the first thing that happens is that the string input multiplier is going to be displayed on the screen, and input is going to expect me to type something in, so it could be 1,000, which is going to be represented as a string, and then I'm going to cast, or if you like, convert it into an equivalent integer by using this operator here, and then assign it to y. So if I execute z and y, I'm going to input a number, and secondly, y is going to be the number I want it to be multiplied by. So the first thing I'm going to do is this is where it gets a bit complicated. I'm going to set the integer variable n to the multiplier, and then I got three variables, and you probably can simplify this a little bit by, if you think about it, the logic of all this. I've got an integer variable count, which I'm going to actually use to count the number of iterations round the while loop. I'm going to set the number I want to be multiplied to the variable num, and I'm going to use TOT for total to accumulate the value of the actual operation of repeatedly multiplying num n times. So have a look at this. While the value of count is less than n, so let's just remember, n is going to be the total number I want the number z to be multiplied by. Count initially is 0, and the initial value of TOT is going to be 0. So have a look at this. Whilst count, which is definitely 0 initially, is less than n, let's say n is 10, then the value of TOT, which currently has been initialized to 0, is going to be assign the value of the value of TOT, which is 0, and I'm going to add num to it. So in other words, total, the first time around the loop is going to be assigned the value of the number z. Okay, that number is z, which is what I typed in here. And the second line of the block of code within the while loop is count is assigned the value of count plus 1. In other words, all I'm doing is to increment the value of count by 1. Well, initially it's 0, so it's going to be increased by 1. Therefore, the current value of count is going to be 1. And I finished executing these 2 lines of code. So go back to the start of the while loop. Whilst the value of count is less than n, whilst the value of count is now 1, is strictly less than 10, repeat what you've just done. So the new value of total is going to be the old value of total, which is 10, and you're adding 10 to it. So the value of TOT is 20. And the value of count was 1, it's now going to be 2. So I've finished executing the 2 lines of the while loop. So while the value of count is less than n, which is 10, so while 2 is less than 10, execute the following. So what I'm doing here is simply to add another 10 to the value of total, which is 20, and that gives me a new value of total, which is 30. So then I'm going to increment the value of count by 1. So the value of count is 3, while 3 is less than, and so on, and so on. And I think you can work out the fact that when the value of count is 9, so we've actually added the number to the variable TOT 10 times, I'm going to jump out of the loop, because when the value of count is 10, 10 is not strictly less than 10, but I will have actually added number to total, a total of 10 times. Remember, 0, value of count was 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the condition fails here. When count is 10, is strictly less than 10, which is false. I'm going to finish the loop. The count has reached n minus 1, so we're out of the loop, and all we do is to print the value of total. So I can't remember what the value of the number to be multiplied. Perhaps it was 2, I can't remember. But we've multiplied it by 10. Therefore, the value of total should now be 20. We've multiplied 2 10 times. All right, 2 times 2 times 2 times 2, 10, 2 by 10 in other words. We multiplied the number sorry, we've been not multiplying at all. We're adding here. So the value of TOT is in effect 2 plus 2 plus 2 plus 2 plus 2 plus 10 times. So it's going to be 20, the value 20. Okay, we looked at the for loop last week, and here I'm giving you a similar definition of multiplication by writing def mult zy, and I've got a single variable total, which is 0, and a new variable which I don't have to declare because it's implicit that range of y is going to be, as it was before, 10. So the range of 10 is just this, if you recall. It's all the values 0, 1, 2, 3, 4, 5, 6, 7, 8, up to 9. So we've got 10 values from 0 to 9. So any value of y1 in that range, what you're doing is to increment the value of total, which initially is 0, by the value of total, which again is 0, plus the value of, I guess that should be, this should be y1. So I don't know whether I can just mark that as being an error. So this should be, that should be y1. Okay, so let's just go through that again. The initial value of the variable total is 0, and for each value y1 in the range of y is going to be added to total in turn. So total initially is 0, it becomes, new value is 0 plus, well, the first value in the range is 1. And the second value, second execution of this line in the loop is that y1 now becomes 2, so the new value of total becomes 1 plus 2, and then you're going to loop again. The third value of y1 is going to be 2, so the value of total is going to be 0 plus 1 plus 2, that's 3, and so on and so on. And after you've executed these lines, you're going to return the value of total. So it's, in effect, I don't know what we're doing here. No, I've got all that wrong as well. So I've made a mistake now. So we are doing multiplication, and what this for loop is actually going to do is to add the number z to itself y times. So let me just get rid of this. I'm sorry, I'm feeling a bit sleepy at the moment. So let me just remove that with a cross. So that one, for fear of boring you a little bit. So for y in the range of y, so y is going to range from literally 0 all the way up to the value of 9, which, as I said, was 10. And each time round the loop, total is going to be incremented by the number z, which is 2. That's the number that we want to multiply by 10. So the initial value of total is going to be 2, then 4, then 6, then 8, and so on. And eventually, when you get up to the value y1 equals 9, you can return the value of total, which is now going to be 20, the value 20. So just spend a bit of time working through that, make sure you understand it, and if you don't, just come back to me. So you could actually write something like the function that we've just defined to multiply 10 by 10. And what Python will do is to immediately write 100. Okay, so you could rewrite what we've just done in this way. So have a look at this as well. I'm speaking in terms of multiplying a number by some multiplier or other, and then simply printing the results. And just to round things off, I'm offering you once again the recursive definition of the multiplication function mult. And I could write this very simply as, okay, here we go, keyword def, name of the function, recursive multiplication, and it's going to take a number z and multiply it by a number y. So here we go. Notice that the block of code is all indented by the same amount. I've got an if statement here, so it's going to be indented by a further 2 spaces. And the E here is going to be indented by the same amount as the if. And then in the else statement, return is going to be indented by a further 2 spaces. So if y is 1, I'm going to simply return z. If I'm multiplying any number z by 1, I'm just going to return the number z. Otherwise, or else, I'm going to return the result of adding to z the result of recursively multiplying z by y minus 1. So I want you to understand that. I want you to intuitively grasp why I'm writing things like this. I've got a recursive, what I call a recursive definition of multiplication. And the reason it's called a recursive definition is that I'm defining recmult in terms of, look, here it is, recmult, but it's recmult on a simpler set of arguments. It's y minus 1 instead of y. And eventually, if I unpack recursive multiply z and y minus 1, I'm going to add 2 to the result of recursively multiplying z by y minus 2, then y minus 3, and y minus 4, y minus 5. And eventually y will become 1, and then I can stop the computation here using this clause, this line here. And if you're interested in that, just try 2 recursive multiplications. Firstly, 2 by 1, and then 2 by 3. So look at recursively multiplying 2 by 1. So if I plug in 2 here and y is 1 here, I get this. And to recursively multiply 2 by 1, I need to check to see whether this parameter y is equal to 1. Well, it is. So it tells me return the number z. So I'm just finished. To multiply 2 by 1 is just 2. But on the other hand, if I'm recursively multiplying 2 by 3, first of all, I'm going to check to see whether 3 is 1. Well, it's not. So what I do is to add 2 to the result of recursively multiplying 2 by 2. And you can work this out separately. You use the same definition, and you'll see that to multiply 2 by 2 recursively gives you 4. So the answer is, if you were to recursively multiply 2 by 3, you're going to get 8. That's 2 plus, to recursively multiply 2 by 3, you're going to get 6, not 8, 6. So it's 2 plus 2 plus 2. Right? 2 plus the result of multiplying 2 by 2, which is 4. 2 plus 4, that's 6. So a little bit more, if you want to, just a little bit more explanation. And I'll finish there. So what I've done is to link today's reflections on multiplication and how to do multiplication in Python to the work we did about, what is it, really 5 weeks ago in the computer architecture session when we looked at the use of opcodes and memory addresses to perform what in effect was the multiplication of two numbers. Okay, so thank you for your attention.